day. My name is Sinusoidal Wave, and today we're gonna learn about the sinusoidal wave. So, do you know what is sinusoidal wave? So, let's go.
So, what is a wave? A wave is a disturbance that travels through space and time, transferring energy without the net movement of matter. Waves can be transverse oscillation perpendicular to the direction of travel, or longitudinal oscillation parallel to direction of travel. Sinusoidal waves are a specific type of wave with a smooth, repetitive oscillation. What is a sinusoidal wave? Sinusoidal wave or sinusoid is a periodic wave whose waveform shape is a trigonometric sine function. In mechanics, as a linear motion over time, this is simple harmonic motion. As rotation, it corresponds to uniform circular motion. A sinusoidal wave, also known as a sine wave, is a periodic wave that can be described by the sine function in trigonometry. So, next is sine wave. So, what is sine waves? Are characterized by the amplitude and period. The amplitude is the maximum value of a voltage or current. The period is the time interval for one complete cycle. So the next is example of sinusoidal waves. So this is graph of the sinusoidal waves. So this lines is for the y-axis, and the up down is the negative, which is the relative minimum, and the upper is the relative maximum. So this is the positive and this is the negative, and the center is the x-axis, and this broken line, which is the relative maximum, and the other broken line is relative minimum. So as you can see in this one graph is what you call one cycle is equals to period. So as you can see, we have two waves, and the one is y equals cos and y equals sine, and the difference of two is the y equals cos is starting at the relative maximum broken line. So dito siya mag-start ang cos. If sine is mag-start in the x-axis. So yeah, that is our x-axis. The cos is first step is the pi over 2, and the third step is 3 pi over 2. Second step is pi. We have the pi over 4, pi over 2, and 3 pi over 4, pi, 5 pi over 4, and 3 pi over 2, and 7 pi over 4, and 2 pi. So next, for sine function and for cos function. So for that example is we have the y sine x, and the positive, which is sine x is x equals pi over 2 or 90 degree. So as you can see, we start at the x-axis, and our first step is the pi over 2. Pi over 2 is belong at the relative maximum, which is the positive. So for the negative one is sine x, x equals 3 pi over 2 or 270 degree. So as you can see, the cost is we start at relative maximum, but we stop at the pi 3 pi over 2. So we stop at 3 pi over 2 the next step. So as you can see at the graph that the 3 pi over 2 in the sine is under at negative 1. So yeah, that is. So for cos function, y equals cos x. The positive 1 is equals cos x. X equals 0. So the positive cos is 0 because we do not undergo at the positive, which is the relative maximum. We go on in the negative 1. So that is 0. For the negative 1 cos x, x equals pi over or 180 degree. So the first step of cos is the pi. So that is our negative 1 pi or 180 degrees. So next, the general form. So the general form of sinusoidal wave is y equals a sine open parenthesis bx plus c close parenthesis plus d, where a equals amplitude or height, b is the change in period defined by 2 pi over b, c is the horizontal shift, and d is the vertical shift. A amplitude and b is equal to 2 pi over b, and frequency is equals to 1 over period, and phase shift is equals negative c over b, which is the horizontal shift. The vertical shift is equal to d. So that is our formula for the sinusoidal wave. So next is our first example. So this is the given. Given y equals 3 cos open parenthesis 1 over 3x close parenthesis. So is here amplitude is equals to 3 because 3 cos, so yeah, it's 3. So the period is equals to 2 pi over b, which is here formula. So 2 pi over 1/3 because our b is 1/3, so equals 6 pi. So for that we need to use the calculator for to show our answer if it is correct. So wait lang, I get my calculator. Okay, so here's my calculator. So we put 2 pi over 1/3. So yeah, so the answer is 6 pi. Sorry for not too clear to see, but yeah, 6 pi. So we put the 6 pi at the x-axis for our sign for where we put the point or tuldok. So yeah, we put the 6 pi, and then we put 6 pi, and then after that we draw the wave to for the final answer. So we do wave, and yeah, oh, I'm sorry for my draw, it's not nice and not clear, but that's okay, nobody's perfect. So yeah, that is our graph. So that is our answer for the given number 1. So that is our graph for given 1. So here's our example number 2, our given number 2. So given y equals 2 sine open parenthesis 4x close parenthesis negative 3. So a is equals to 2 because that is our a or amplitude. So the b is 4 and this d is negative 3. So period is equals 2 pi over b is equals to 2 pi over 4. It's equals to pi over 2. So we don't have phase shift because we don't have c in the given. We for sure our answer we calculate, as you can see, we calculate 2 pi over 4. So what is the answer is pi over 2. So yeah, so I repeat, no, we don't have phase shift because we have no c as the general form, and then the vertical shift is equals to negative 3. So yeah, so negative 3 because that is the given. So we have here the graph. So now we need to graph. So this is the pi over 2, which is the period. So the our vertical shift is in the negative 3. So we put our point in the negative 3 for our broken line. So we point negative 3. So we put that in a, so I repeat, this is our graph for the given number 2. So we have the pi over 8, pi over 4, and 3 pi over 8, and pi over 2. So this is our graph. So the negative 3, which is the vertical shift. So we put the point at the negative 3 for the broken line. So we draw a broken line for our wave. So yeah, that is, and then we put the point in the pi over 8 in the, which is the negative 1, because negative 3 over minus 2 equals negative 1. So yeah, so next is we put the pi over 4, and the next one is negative pi under 8, 3 pi over 8. I'm sorry. So yeah, that is, and the last one is the pi over 2. So after that, we connect that to form a wave. So yeah, again, I'm sorry for my drawing. I'm not perfect for that, but yeah, at least I give my best to draw. So yeah, that is for the example number 2. So yeah, I fixed that, and yeah. So that is for the example number 2. So we proceed for the example number 3. So here's our Example number 3. So the given is negative 3 cos close parenthesis open parenthesis 1 over 2x close parenthesis plus 5. So as you can see, our amplitude is negative 3 and our period is, the formula is 2 pi over b. It's equals 2 pi over 1 over 2. It is equals to 4 pi. So our vertical shift is equal to 5. So that is our vertical shift. That is the 5, positive 5. So we draw the broken line already. And the other point is in the 2. Because 5 minus negative 3 is 2. So yeah, that is the, and then we put the other point in the pi and 2 pi, and then the next one is in 3 pi, and last one is the 4 pi. So after that, we draw or we trace for the wave. So yeah, that is, again, I'm sorry for my drawing. And yeah, so that is the draw for the example number 3. This is the next example. Given y equals 2 sine open parenthesis x minus pi over 2 close parenthesis plus 3. So a is equals to 2, which is the amplitude, and the period is equals to 2 pi over b. Is equals to 2 pi over 1. So that is our p. So equals to 2 pi. Phase shift is negative c over b. That is our formula. And this equals to negative pi over 2, which is our c, is equals to pi over 2. Our vertical shift is the positive 3. So yeah, so we have the already graphed and the broken line. So the vertical shift is 3, so which is the broken line is in there 3. So next one is we put the point at the pi over 2, it's below the 3, and the next point is in belong at pi, because 3 we need to plus 2, which is the amplitude, is equals to 5. So 5 belong to pi. Next is 2 pi, which is the 1, because 3 minus 2 equals 1. So the last one is the 5 pi over 2. So we put that in the 5 pi over 2. So after that, we connect for our wave. So we already connect now, and that is our example for number 4. May I write example number 4? Oh yeah, example number 4. So next, the example of number 5. So given is y equals 3 cos open parenthesis 1 over 2 x plus pi close parenthesis minus 5. So the amplitude or A is equals to 3, and the period is 2 pi over B is equals to pi over 1 over 2 is equals to 4 pi. The phase shift is negative C over B is equals to negative pi over 1 over 2 is equals to negative 2 pi. And the vertical shift is equals to D, which is the negative 5. So here's our graph. So this is, we have the negative 2 pi and negative pi and 0 and pi and 2 pi. So our vertical shift is the negative 5, so we put the negative pi, a point at the negative pi. But before that, we solve first the negative 2 pi plus 4 pi equals 2 pi, so that is our 2 pi at the other side. We put our point at the negative 5 and the negative 1 at the 2 pi, so the negative pi is, we draw the broken line. Now we have all point, and the next one is we draw for the wave. So that is the draw for the wave for the example number 5. So that is the example of number 5. So let's proceed to example number 6. Example number 6, we have the given negative 2 sine, open parenthesis, 1 over 3 x minus pi over 2 plus 3. So our amplitude is equals to a is equals to negative 2, and period is 2 pi over b is equals to pi over 1 over 3 is equals to 6 pi. Phase shift is negative c over b is equals to negative pi over 2 third is equals to 3 pi over 2, and the vertical shift is t is equals to 3. So here's our graph. So the vertical shift is 3, so our broken line started at 3. So that is, before the other, we solve first. 3 pi over 2 plus 6 pi is equals to 15 over 2 pi. Next one is 3 plus 9 is equals 12 over 2 is equals to 6 is equals to 3 pi. And the next one is 3 plus 15 is equals to 18 over 2 is equals to 9, which is the 9 pi over 2. And that's all. So next is we put the first step in 3 pi over 2, and the next one is 3 pi, and the next one is in belong in 3 and 9 pi over 2, and the next one in 6 pi, it belongs in number 5, and the last one is the 15 pi over 2, it belongs to positive 3. So let's draw and trace the point. So that is our wave for this example number 6. That's all for the graph and example number 6. I'm sorry again for my draw.